Hello, pre-calc people. So today we're kind of solidifying what we gave you a little bit of a preview of in the last chapter, the relationship between the arc trig and your inverse trig. One is a relation, that would be the inverse, and one is an arc cosine. I just said that backwards, didn't I? Oh my gosh. Okay. The arc is the one that just keeps going. The inverse is the one that gives you one particular value from a particular region. So we see that your typical sine graph would kind of comes through the origin, goes high, starts on the sinusoidal, going forward and backward. Now the reason why we limit it from negative pi over 2 to pi over 2 is, remember, you want your function to pass the horizontal line test in order to show that the inverse would be a function. That's a good review question for your final. So remember, you want to pass the horizontal line test. It's like a predictor that then your inverse is also a function. So if I limit my sine to between negative pi over 2 and pi over 2, and then find the inverse, that would be represented right here. So we've switched our x and our y axis, because with an inverse you switch the x and the y, and then you go and you isolate your y. So usually sine x for that principal branch, normally it has all reals for its domain, but we're now going to limit it from negative pi over 2 to pi over 2 so that it passes the horizontal line test, and its range is going to go from negative 1 to 1. That's your sine graph. That means the inverse, these will switch. So it has a domain from negative 1 to 1, and so this is your negative 1, and this is your 1. That is our new domain, and the range is going to be from negative pi over 2 to pi over 2. And notice I am using the square brackets, which means the endpoints are also included in our final answer. Now, because of this, like, how do you use this? So the way they choose which quadrants they're going to use is they want to choose two consecutive quadrants where sine is both positive and negative. So sine is positive here. It doesn't want to use the second quadrant because sine is also positive here. So it pulls the other value from here. Now this is what's really hard for people to wrap their head around. This is not the fourth quadrant. This is what I call the pre-first quadrant. All right, it's negative pi over 2 to pi over 2. So your answers will always have the same value, but will have either a plus or a minus in front of them. For instance, solve sine x equals negative 1/2. So that's like saying, so x equals inverse sine negative 1/2. So we know we're going to want an answer that is going to come from the quadrant where sine is negative. That happens to be that pre-first quadrant. Sine is normally 1/2 at 30 degrees or pi over 6. So in this case, we say negative pi over 6. So in some ways, sine is kind of easy in that it's always going to be the same value. So you go, let me choose a different color to show this. If I'm going up, that's going to be a positive ratio. I'm going to say plus theta. If I'm going down, then you just use the negative theta, because it's either in that first quadrant or it's in the pre-first quadrant. And negative pi over 6 is between negative 90 and 0, or negative pi over 2 and 0. All right, now that's hard. Do not give the answer in the fourth quadrant. That is not a consecutive quadrant with that first quadrant. If you were to look at a graph, if you looked at it linearly, okay, the fourth quadrant is way out there. The fourth quadrant, it's out in the distance. All right, With cosine, we already kind of looked at this, so also we are going to limit the graph so that it passes the horizontal line test. And then we switch our x and our y. And you notice, so this now went from, just like before, it's always from -1 to 1. Our domain was normally, so we passed the horizontal line test, 0 to pi and -1 to 1. But the inverse now switches those. So just like the sine, it goes from -1 to 1 on the x coordinate. Here's your -1, here's your 1. The range is now going to go from 0 up to pi. And the reason why we do that with cosine is positive here. All positive ratios are going to come from the first quadrant. Cosine happens to be positive down here in this pre-first quadrant. So we go to the second quadrant to find its negative ratio values. So if I'm solving cosine x equals -1/2, which is like saying find the inverse cosine -1/2. So we want a value. So cosine is 1/2 usually at 60 degrees or pi over 3, but we want where the ratio is negative. So that value is going to happen in the second quadrant with the same reference angle. So instead of 60 in the second quadrant, that would be at 2 pi over 3 if you're in radian mode, or 120 degrees if you're in degrees. All right, so notice that from 0 to, this is pi over 2 right here, that's the first quadrant, and then pi over 2 to pi, that represents the second quadrant. So you're pulling your values from the second quadrant. Tangent is a little different because it has the whole wave thing. It doesn't have a limit on its range. So if we switch the x and the y, notice here, so like tangent, no problem. It completely passes the horizontal line test. So when we go sideways, what we're doing is those asymptotes also turn sideways. Let me get my pen here. They wrote this so tiny, it's really hard to see. I'm hoping I choose to write pi over 2 and -pi over 2. These are still your asymptotes. And your graph keeps going and approaches those asymptotes. So it's a sideways wave. All right, so before with tangent, our domain, now here you have to be careful because the endpoints are asymptotes. So this is open bracket, -pi over 2 to pi over 2, and the range used to be all reals. Well, now with the inverse, the domain is all real numbers, and your range with open brackets because the endpoints are not included. So please be careful of that. Those endpoints are asymptotes. And you should always show your asymptotes. Don't try and hide your asymptotes. All right, so tangent x, oh, and y. Okay, so notice this also does the pre-first quadrant, not the fourth quadrant, the pre-first quadrant, because that's -pi over 2 to pi over 2. Quadrant 1 is where everything's positive, and tangent is negative in that pre-first quadrant. So if I'm solving tan x equals -1, that's like x equals inverse tan, and again now it's a negative value but with the same reference angle. So it's also just like sine, so we want to pull from this pre-first quadrant, which makes it kind of friendly, so I can just say x equals -pi over 4. Because that is between -pi over 2 and 0 in that pre-first quadrant. All right, let's see how we apply this. All right, so this first problem, and you're going to do this again in calculus, use the geometry to find an expression for y equals sine of inverse cosine x. You're like, what? So we want our answer in terms of a right triangle. So let's go ahead and draw a triangle. So we draw a right triangle coming out of the origin. This represents theta. We're going to assume it's a unit circle. And we know that based on this, sine is opposite over hypotenuse, right? And so inverse cosine, now this is cosine x over 1. So that's telling me how to label my triangle. Remember that cosine is adjacent over hypotenuse. So the adjacent will be x. My hypotenuse will be 1. The side opposite I fill out by Pythagorean theorem. So remember, Pythagorean theorem says x squared plus that unknown side squared equals 1 squared. Solving for the unknown side, this is going to be 1 minus x squared. All right, so let me put that out here a little. So what did we do? We did x squared plus, we don't know, that squared equals 1 squared. And then we solve for that blank box. And of course, with Pythagorean, you always have to take the square root in the end. So that's how we got that. All right. So what is the sine of theta, where theta is that crazy setup? Well, sine is the opposite over the adjacent. So sine of theta will represent 1 minus x squared over 1, which is our answer. All right, so let's go back what we did. We used the argument here to label our triangle. So if you tell me that the inverse cosine of x, this is your adjacent over your hypotenuse, that lets me set up my triangle. The sine of theta, theta does happen to be the inverse cosine of x. You read it off of your triangle. Sine represents opposite over hypotenuse, and that's what we have. All right, now let's use some of our special values. Some of these might require a triangle. Some of these might be ones that you should know from your special triangles. All right, so we start off with cosine of inverse sine 3/5. All right, so we use our geometry. So here we go. 3/5 is a positive ratio, so I'm doing it in the first quadrant. All positive ratios come from the first quadrant. Sine is opposite over hypotenuse. By Pythagorean theorem, we know the adjacent side will be 4. And again, this represents your theta. So cosine of this particular theta is the adjacent over the hypotenuse, and that is your answer. That's how you would use the geometry to find it. Let's look at this next one. Secant of inverse tan -3/8. All right, so we use our geometry. Now it's a negative ratio with tangent, so I go to my pre-first quadrant. Here's my theta. Tangent is opposite over adjacent. So notice that you have to determine based on where x and y are positive and negative, where that negative goes. So we know the 8, the adjacent in that quadrant, is positive, the y value is negative. Then we do our Pythagorean theorem, so that's 64 plus 9 is the square root of 73. Well, 73, and then you take the square root. So there we go. There's our triangle. So you're always using your Pythagorean on the inside argument. So now the secant of theta, where this all represents theta, is, again, remember, hypotenuse over adjacent, so that's going to be rad 73 over 8. And that would be how you get that. All right, now let's look at some ones that come from your special triangles where you're not necessarily drawing a triangle. Sine of the inverse sine of 2. Well, let's say you tried to. This would be 2 over 1. Here would be the problem. Sine is opposite over hypotenuse. You can't have a leg longer than a hypotenuse, so that's just bunk. So that one is undefined. That 2 falls outside the domain that we want. All right. Inverse sine 210 degrees. All right, we're kind of switching things up here because we're going to take the inverse sine. Well, let's first figure out what is the sine of 210 degrees. Well, that is a reference angle of 30, right? Because that would put me at 210. And so sine is opposite over hypotenuse, so that is a negative 1/2. These are really tricky, guys. All right, so they're giving us, what is the inverse sine of a negative 1/2? Well, since it's sine, its principal branch comes from, for the negative, comes from the pre-first quadrant. So opposite is -1, the hypotenuse, your hypotenuse is always positive. And so what angle goes there? Because that's what we're looking for, right? That theta goes with negative, since they gave it to us in degrees, we'll give it back to them as negative 30 degrees. Your answers for sine and tangent will always be the same. They will only differ by plus or minus. Positive ratio, first quadrant. Negative ratio is the negative value of what you had in the first quadrant. So that kind of makes it a little, sine and tan, a little bit easier when you're doing these. All right, let's try cosine now. All right, so theta equals the inverse cosine of this cosine, 4 pi over 3. So we want to figure out, so that is 60 degrees, pi over 3 times 4, which is 240 degrees. So 240 degrees is a 60-degree reference angle. So this is a negative rad 3, this is a negative 1, that's a positive 2. So cosine, inverse cosine, is negative rad 3 over 2 when we figure out cosine 4 pi over 3. All right, now that's a negative. So my final answer has to come when you're going to do the inverse. Remember, cosine, positive ratios come from the first quadrant, negative ratios come from the second quadrant. So negative rad 3, oh, I hope you caught my mistake, because that should be a negative 1/2. Thank you, whoever said that. Nobody said that, because it's only me and my dog here, but a little voice in my head, that's your adjacent over your hypotenuse. All right, so we need to pull that value now from the second quadrant, because cosine's only going to come from the first if it's positive, second quadrant if it's negative. 1/2 still has a 60-degree reference angle, so that is going to be 2 pi over 3. All right. Now, I know this is a lot, but here's a nice little shortcut every once in a while. Since they gave us in this problem a value that is in the principal branch, so the plus and the negative, when I'm taking the inverse cosine, and this falls within one of the principal branches, these two will just undo each other, and I get 2 pi over 3. It's the same thing as if I had said, what is the inverse cosine of cosine pi over 3? Those would cancel, and my answer would be pi over 3. And if you don't believe me, which sometimes people don't, you can work it out the long way. Think about what is the cosine of 2 pi over 3 is a negative 1/2. And so we want to pull our value from the second quadrant, and voila, there we go. So it's not that bad. You can get there either way. But when the value they give you falls within the principal branch, the cosine and the inverse cosine, the sine and the inverse sine, the tan and the inverse tan will cancel each other out. All right, just to give you one more example, let's say if it was a sine, if I had asked you what is the inverse sine of sine 11 pi over 6, well, no, that actually, no, it does that. That would, I want something that comes from the pre-first quadrant, of sine negative pi over 6. There we go. Since negative pi over 6 is in the principal, the pre-first quadrant where we pull sine from, these two would cancel and your answer would just be negative pi over 6. As opposed to, let's go back to what I did try and just do. If I did sine 11 pi over 6, which actually is coterminal, your answer would be the same. It would be negative pi over 6. Your final answer has to come from either the first quadrant if it's a positive ratio, or the pre-first quadrant if it's a negative ratio. And I love this little diagram to kind of highlight what's happening. So if it's an inverse cosine or inverse secant, and they're just reciprocals, cotangent we'll talk about in a bit. So everybody that's positive comes from the first quadrant without fail. It's where things are negative. So in the second quadrant, you have your inverse cosine is going to come from here, your inverse secant, and believe it or not, your inverse cotan. That one's going to be the tricky one. Then we have, if it is a sine, we know that it's going to come, positive again is going to come from the first quadrant, negative for sine, inverse tan, and inverse cosecant, since those two are just reciprocals of each other. And again, this is not the fourth quadrant, it is the pre-first quadrant. So we're talking negative pi over 2 to pi over 2. It's got to fall in that range. So negative pi over 3, negative pi over 4, negative pi over 6, those would all be legitimate answers. The other thing, remember with the tangent, you would always have open brackets if you're stating a range because the endpoints would not be included. Like if I asked you what's the inverse tan of negative pi over 2, you should say undefined. That's an asymptote. All right, I hope this helps.